Example 3. What are the concentrations of the ions in a mixture prepared by adding 3.60 gram sodium chloride into a 75.0 milliliter of 0.250 molarity calcium chloride solution? Assume that the volume does not change when solid sodium chloride is added. The first step is always to summarize the most important information. The most important information includes numbers with units, what we are looking for, and balanced chemical equations if there are chemical reaction in the problem. Since we are looking for the concentrations of the ions, but we are provided the chemical formulas of the chemicals, therefore, we need to write down the balanced chemical equations to show how the chemicals break down into ions. As a rule of thumb, whenever you have a balanced chemical equations, the best habit is put down the numbers with units below the corresponding chemical under the chemical equation. From the balanced chemical equation, we can say that the solution will contain 1, 2, and 3 ions. Therefore, if we are looking for the molarity of the ions, we need to calculate 3 molarities. Let me remind you one small thing. When we add sodium chloride into the calcium chloride solution, we will create one solution. Therefore, there is only one molarity for chloride, not 2. What I'm going to do first is to calculate the molarity of the sodium ion. Let's start from the definition of the molarity. This is the definition of the molarity of the sodium ion. It is defined as the moles of the sodium ion over the liters of the solution. Let's see what information we already know. From here, we know that the volume should be the same as this volume. If we want to calculate the molarity of the sodium ion, we have to know the moles of the sodium ion. Since we are given the balanced chemical equation, if we know the moles of sodium chloride, we can calculate the moles of the sodium ion. Because we are given the mass of the sodium chloride, we can convert to the moles of the sodium chloride. Because we know the chemical formula, we can calculate the molecular weight of sodium chloride. To use this map, we can start from places whenever there's no arrow pointing to. The third step of this method is to work out the details of all steps. Let me show you the details. To calculate the molarity of the chloride ion, we have to conduct a similar analysis as we did for the sodium ion. Let's start from the definition of the molarity. The molarity of the chloride ion is defined as the moles of the chloride ion over the liters of the solution. From the previous calculation, we already know the volume of the solution in liters. To calculate the molarity of the chloride ion, in addition to the volume of the solution, we have to know the moles of the chloride ion. From the balanced chemical equations, we know that both the solid sodium chloride and the calcium chloride solution provide the chloride ion. We have to add the two parts together. Now let's see if we can calculate the moles of the chloride ion from the sodium chloride solid, and if we can calculate the moles of the chloride ion from the calcium chloride solution. Since we know the balanced chemical equation, we can use stoichiometry to calculate the moles of the chloride ion from the sodium chloride solid. In other words, if we know the moles of the sodium chloride solid, we can calculate the moles of the chloride ion by using stoichiometry. From the previous calculation, we already know the moles of the sodium chloride solid. Then let's see if we can calculate the moles of the chloride ion from the calcium chloride solution. From the balanced chemical equation, if we know the moles of the calcium chloride, we can calculate the moles of the chloride ion from the calcium chloride by using stoichiometry calculation. Remember, these two arrows is just one step. These two arrows is just one step. Since we know the volume and the molarity of the calcium chloride solution, we can calculate the moles of calcium chloride. To use this map, we always start from places whenever there's no arrow pointing to. Step 1, step 2. Sorry, this is one step. The next step, and it is also the last step, we need to show the work of all steps. Now let me show you the work. Step 1 and step 3 are stoichiometry calculations. These two fractions are also called conversion factors. They are from the balanced chemical equations. Can you follow a similar procedure to work out the molarity of the calcium ion by yourself? Can you follow my example to work out this problem by yourself?